The goals of this video are to demonstrate knowledge of relationships between angles in an inscribed quadrilateral and to demonstrate knowledge of relationships between an angle and an intercepted arc. So we have two vocab words here. We have inscribed angle and intercepted arc. So an inscribed angle is an angle that is on the inside of a circle. It is made of two chords that share the same endpoint. The vertex of our angle is always going to be on the circle. So right here, this angle is an inscribed angle. Its vertex is on the circle. The intercepted arc then is the arc that is formed by the given angle. So this would be our intercepted arc between the two openings of the chords. The measure of an inscribed angle is half the measure of the intercepted arc. So if our angle is measure angle ABC, we could say this angle is 50, which means that its intercepted arc AC would be 100. So the relationship then is that your angle is equal to half the measure of the intercepted arc. So let's use that to find some angles and arc measures. In number one, we want to find the measure of arc ME. So we know the angle is 62 degrees. So if we are going from angle to arc, we want to double it. So we're going to do 2 times 62 degrees, and we get 124 degrees. Number two, we want to find the measure of angle CHI, which is the angle over here. Remember that the angle is half of the arc, so we want to take half of 98, and we get 49 degrees. In number three, we want to find the measure of arc CS. In order to do that, we need to use these inscribed angles. So if this angle is 83 degrees, it intercepts the arc CU. So when we double that, we get 166 degrees. Then we see the 130 degrees is intercepting from S to U. So it's going to be a major arc SCU. So this whole arc, when we double 130, is going to be 260. So to get arc CS, we can subtract. So the measure of arc CS is going to be 260 minus 166, which will be 94 degrees. In number four, we want to solve for x. So we see that these chords are marked congruent, which means that the arcs are going to be congruent, so those are both going to be x. We also see that 41 is intercepting this arc, so we can double 41 to get our arc of 82 degrees. We know in a circle that there's 360 degrees. So we have 2x plus 82 is equal to 360, and we can solve for x. So first we're going to subtract 82. So we get 2x equals 278. And when we divide by 2, x is 139. So each of these leftover arcs are going to be 139 degrees. So x is 139. In number five, we know one of the arcs is 119. We know that this 38 degrees is intercepting this arc, so we can double 38 to get 76. So to find x, we know that 119 plus 76 plus x is equal to 360. 119 plus 76 is 195. So we have 195 plus x equals 360. We can subtract 195 to get that x is 165 degrees. In number six, 114 is a central angle. So a central angle, remember we have talked about earlier in this chapter, is the same measure as the arc, which means this is 114 degrees. X, this angle, is also intercepting the 114 degrees. Because x is an inscribed angle here, we want half of that arc. So x is equal to half of 114, which would be 57 degrees. So let's look at another property. If two inscribed angles intercept the same arc, then the two angles are going to be congruent. So if we see that angle B is intercepting arc AD, and angle C is also intercepting arc AD, that would mean that these two angles B and D are going to be congruent, which means they would have the same angle measure. Also, an inscribed angle that intercepts a semicircle if and only if it is a right angle. And the reason that this makes sense, a semicircle is half of a circle. So if a circle is 360 degrees, half of that is 180 degrees. Well, this angle then has to be 90 because it's half of the 180 degrees. So let's use these ideas to solve for x and find some more angle and arc measures. So in number 7, find the value of x. So this line right here is going to be a diameter, which is intercepting our semicircle, which means that this angle has to be 90 degrees. So we have x squared minus 54 is equal to 90. We add 54 to both sides, so x squared equals 144. Remember, when you take the square root, we have to include the plus or minus. Usually we get rid of the minus when we're doing like Pythagorean theorem because we know side lengths can't be negative. But in this case, we're going to keep the negative. So when we take the square root of 144, we get 12, so x equals plus or minus 12. So we would keep both solutions in this case. In number 8, we want to find the measure of arc ZL. Well, we see that angle D and angle E are both intersecting that angle, so we know that those are congruent. 3x plus 30 is going to equal 8x minus 15. So we get 45 equals 5x. When we divide, x is 9. Now that we know x is 9, we need to substitute back in to get our angle measurement. So we can pick either angle. I'm going to pick 3 times 9 plus 30 gets us 57 degrees. So remember, the angle to the arc, we need to double our angle. So if our arc is 57, we would do 2 times 57 to get 114 degrees. So our arc is 114 degrees. Number 9, solve for x and y. Well, again, we see that we have a diameter, which is making our semicircle. So we know that this has to be 180 degrees. So x is the inscribed angle of that arc, so we know that x has to equal 90 degrees. Then to get y, we see that it's a triangle, and in a triangle we know there's 180 degrees. So y is going to equal 180 minus 41 minus 90, which would get us 49 degrees. Number 10, find x and the measure of angle 1. So these two angles that we both have x are intercepting this angle. So this arc. So 5x plus 4 and 7x minus 30 are going to be equal to each other. So we're going to use that to find x first. So we get 2x equals 34. X is 17. Then, to get the measure of angle 1, we know that angle 1 is intercepting this arc, and so is 4x. So we know that those are congruent. So we can do 4 times 17 to get 68 degrees. So the measure of angle 1 then has to be the same, which is also 68 degrees. Our last property of the day. If a quadrilateral is inscribed in a circle, which means that it's inside the circle and its vertices are all on the circle. So we see B, A, C, and D, the vertices are on the circle. Then the opposite angles have to be supplementary, which means that they equal 180 degrees. So the measure of angle A plus the measure of angle C has to equal 180, and the measure of angle B plus the measure of angle D has to equal 180. And the reason that works, if I look at angle A is intercepting this arc. Angle C is intercepting this arc. So together, they're covering that 360 degrees, and because they're inscribed angles, they have to be half of that 360 degrees. So let's use that property in a new problem. In number 11, find the measures of R, S, T, and U. So right now, we know that R and T are opposite angles, so they have to be supplementary, so we can use that to solve for x. So 6x plus 20 plus 3x plus 25 is equal to 180. So we get 9x plus 45 is equal to 180 degrees. We can subtract 45 from both sides. 9x equals 135. When we divide by 9, x is 15. So now that I know x is 15, we can substitute 6 times 15 plus 20 gets us 110 degrees. 3 times 15 plus 25 is 70 degrees. We can also see that those two numbers together add to 180, so we know we did the problem correctly. Then to solve for y, or s and u, we would do 10 times 15 minus 69, which gets us 81 degrees. And we know that u has to be supplementary to s, so we're going to do 180 minus 81 degrees, and that gets us 99 degrees. So let's move down to our last question on the notes. So given circle F, find each of the measurements. So we know that this angle 51 degrees is intercepting this arc. So we know that that's going to be 102 degrees, which is arc AB. That was one thing we had to find. We also need to find the measure of arc DC. So unfortunately, we don't have any angles that are intercepting this arc. So we can use the other angles, though, to find the other arcs. So we know that 43 is intercepting this arc. So when we double that, we get 86 degrees. And we know that 32 is intercepting this arc, so we can double it to get 64. Now that we know 3 of the arcs of the circle, to get that 4th arc, DC, we can subtract from 360. So 360 minus 86, minus 102, and minus 64. And that gets us 108 degrees. The last part that we want to find then is the measure of angle A of BAD. So BAD is this whole angle right here. It is intercepting these two arcs. So 64 and 108 added together gets us 172 degrees. So to get the measure of that angle, it is going to be half of the arc. So half of 172, and we get 86 degrees.